Hello, welcome back to More Fun Fixing It. I'm at the start of a Commodore 64 journey. I've got a number of Commodore 64s over here. I forget how many. I think there's 5. There's one bread bin, sorry, one C64C and a number of bread bins. I'll get them out in a minute. But I've also behind all of this lot, I've got a box of Commodore 64 silver label bread bins, 4 of those. And another Commodore 64 bread bin silver label. This one, which is the super low serial number 0882, made in West Germany, silver label, that is in marvellous condition. I've got the LED lead still sticking out the side of it here, but that's okay, that'll be all right. And this one is waiting for repair. This is one I've shown on my channel before, where I asked for opinions on what other people thought would be the problem and how they would fix it. So after I fixed all of the regular run-of-the-mill ordinary C64s, I'm going to then fix the 4 other silver labels, which are not super low serial number C64 silver labels, but they are still silver labels. So I'm going to work my way up to those, and eventually I'm going to finish on this one. And by the time I get to this one, I'm hoping I'll be good enough to fix it. So to start with on the bench, I've got my test bench, and everything I need to be socketed in here is socketed. I've got one of the RAM chips is socketed. These multiplexers are socketed. I'll probably end up socketing these logic chips when I come across a machine that's faulty and I need to test them. But logic chips aren't so difficult to test outside of the C64. You can use something like a TL866 or a T48 programmer to check logic chips. It's not an infallible way of checking logic chips, but it does work. Obviously got the SID and the PAL and the VIC2 are socketed. There's one of the timing chips in here is socketed on this 250-407 revision board. So I've got everything I need to actually diagnose by swapping chips. But I've also got lots of other tools. I've got oscilloscopes, multimeters, and test cartridges. So this one is working. You can see that the display is showing a normal C64 screen. So let's turn this one off. I'm just verifying that this one is working before I start, which is always a very good idea. So we've got 1, 2, 3, 4, and this really disgusting one, 5. This is the one that's full of dead spiders. Should we do this one first? I quite like the look of this one. Yeah, we'll start with this one. Let's get these off the bench with some whooshy sound effects. Might have bitten off more than I could chew with this one. I seem to remember it was quite rusty inside. So I've already taken it apart. You would have seen this if you follow my channel in a recent triage episode where I triaged all of these C64s and gave them a quick first look, plugged them in, tried to diagnose quickly what was wrong. So the best guess on this one is really dead spiders. It's full of, well, it was full of dead spiders. I don't know where they've all gone. Okay, that's going to keep me awake at night. There's one of them there. Let's get this out of the case. See how many more spiders are living underneath it. All right, there's only 2 screws. There's not too bad, actually. There's a few bits down here. That's not too bad. I've seen a lot worse. I've got a lot worse, actually, in this workshop. On the back side, oh, it's right. Okay, so this area here looks like it's been water damaged. So that is all around this area. So we're looking at the SID and the PLA. Before I turn this one on this time, I'm going to take this SID out. And you can always tell, I know some people have a way of telling which way around, because the SID and the PLA can be swapped. The PLA can be on a 250-407, for instance. This is a 250-425. The PLA can be here and the SID can be here, but I always tell by these 2 little capacitors right here. They're always next to the SID. So we'll put that to one side. We have still got quite a lot of spider debris in here. Yeah, I think this is probably just voltages maybe, or could be is the fuse bad? Let's check for fuse first. Right, so multimeters on continuity mode with the beep enabled. And we have a good fuse. So I'm going to put that on voltage now, and let's plug this in, see what blows up. Right, first of all, what do we get on the display? We get a white line on the left-hand side, which is a good sign. That means we've got video sync over here, so the VIC and this chip and the crystal and everything are probably okay. And yep, 5 volts coming out of the 7805, and the 12 volt is there, and 5. Oh, am I on the wrong one? And that should be, that's what, probably just a extraordinarily crusty edge connector. Just give those a quick. Right, 4.8 volts there, and AC 10 volts there. So 4.8 is quite low, so I reckon something is shorted here. That white line on the capture is getting very bright. Okay, so the next stage is, I would normally put in a test cartridge. In fact, I'm going to do that. It's normal for me, so let's do it. I think we're going to go for Des Test Max first. Oh, this is the one we get absolutely nothing from, isn't it? So I'm going to just cycle through all of the diagnostic tests. I think I'm on dead test now. Still not doing anything. Normal diagnostics won't do anything. Right, so scope. Let's look for clock first, which pin 1 is the clock in on the CPU. That's a good clock. And the clock out of the CPU is here. That's good. And the next thing to check is the reset line. So it's a bit quick, but I still think that's okay. Now what? This one is much more tricky. I'm pretty sure I already reseated the VIC2 in the previous video, so I don't want to be touching that because that socket is not very good. The most likely thing here is it's the PLA. A good way of testing that is the ROMs, seeing if the chip select lines are working, or the chip selects are working on the ROMs, which I think is pin 20, but I'm going to just check that. Okay, so I've looked it up, and all 3 ROMs have the same pin out basically for the chip select, which is pin 20. Oh, there is something on there now. There was nothing on there a second ago. So this is the character ROM, which is getting selected. This is the kernel ROM, which should be getting selected a lot. And that's just high. And this is the basic ROM, which should get selected in a burst at the start and then stop. But what's worrying me here is that the character ROM is getting selected, and in a normal way it looks like that could be a true chip select for the character ROM, and I was hoping that all 3 of them would be high and that the PLA would then therefore be the main culprit here, and it still is. It's a MOS PLA, but one of them is, well, it could just be that one of them is naturally, you know, selected because by default, or I don't know. All of the pins on this ROM, on the PLA, are high. Okay, that looks like a clock. Yeah, there's no activity. It's just everything's high. On this side, there's only this pin here. That's that same signal, isn't it? Yeah, that's that same signal. That's going to be the character ROM. And there's another clock. That's a data line, I think. So that's low, that's probably ground. High, 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 high. Yeah, I'm not sure I've ever seen a more suspect looking PLA. Would you like to see, just for comparison, just to show you what a normal PLA looks like as a learning experience for all of us? Working C64. And the PLA is up here on this one. But let's go to the chip select lines on the ROMs first. There's not much battery left in my scope. So that's that's the character ROM. It's very, very busy. And that is the kernel ROM, which is also very, very busy. And this is the basic ROM, which you see is looks high. But if I turn the computer off, if I hold the probe on there, turn the computer off, you see, ooh. All right, and yeah, there's a burst as basic is initialized there, and then it stops because it's not doing anything. It's not being accessed. That's more normal. Oh, let's have a look at the actual PLA as well. Just show you that this is more normal activity done. Everything along this side was high on the other one. And that's, to be fair, there's a lot that is just high, but there's that clock. Oh yeah, it's not very different, is it? There's a bit more activity there and there. This will be the chip select lines down there, I think. And there's some more data lines up here. There's a lot more activity on this chip than the other one. But then again, it's a working system and you would expect there would be more activity. Maybe because the PLA is not working, or because something else is not working on the other one. That's why there's no activity on the PLA. It's really difficult to tell. One more test. One more thing I want to try. We know we've got good voltages. We know we've got clock. We know we've got reset. We've got slightly suspect looking PLA. Oh, what about temperatures? Okay, so all of the RAM looks okay. That's all the RAM down there. Normal temperatures. And this is, I think that's the color RAM. Yep, which is often a bit more toasty than the chips around it. The PLA is now up to 49.1 and climbing, 49.9, 50.2, 50.4. It's climbing quite rapidly. The CPU is also up near 50 and just about to breach 50 degrees. The ROMs look 41, yeah, 40 and 41 for these two ROMs. So it could be these and not the PLA. And the CIAs look okay. But it could just, at this stage, it could be anything. Oh, and the VIC2 is the toastiest at 54. Very closely followed by the PLA. Nothing else. Ooh. Oh, it's bridge rectifier. Nothing else looks out of the ordinary. I think at this stage, I'm probably more inclined just to whip the PLA out and test it in my machine. And having seen how, I think the CPU's okay. I think it is. It's just the major suspect, but we could end up pulling loads of chips out of this. But for now, I think the easy win, without going too deep into the schematics, the easy win is going to be the PLA. It's just the most likely thing. So what I'm going to do is reflow all of the solder joints on the PLA, which is here. I like to mark these things so that I have less chance of desoldering the wrong thing. Reflow all of the pins. They're very, very short, the pins on these. It's not good. And desolder it using the desoldering gun. And the desoldering gun I'm going to use is this thing. Gauzy S993A. which is a kind of a cross between a Hakko FR301 and a ZD915 for you desoldering gun aficionados. And I bought this so I'm making a video about the differences between the ZD915, which I've now got back, and the FR301 and this. You'll see that as a main channel video in the future, but I need to use it, and that's what we're doing today. Oh, my soldering iron wasn't switched on, but what I love about this Sugon A9 is how quick it heats up. So it is now heated. It's so fast. Okay, I'm just noticing that all of these pins are bent over outwards, so I'm straightening them, trying to get them more into the middle of each hole so that it's easier to get the nozzle on there without damaging anything. Just straighten these ones up as well. Wonderful. This is an angry little tool, this one. It's rah, rah, rah. It's like a little terrier. I wonder if that's blocked. No, no blockage. All right, a couple of them didn't desolder very well, but most of them seem to have cleared really well. I think I was just a bit too quick on these two, and they just needed a bit more melting. Okay, that worked reasonably well. Let's see how there's quite a lot of solder still left on the top, so I'm going to have to heat this from the top to free it up. It's not a pass. Not a pass. Hot chip. Leave it on there to cool down. That took some getting out, actually. There's still quite a lot of solder left on top, especially that point there. It didn't look like it desoldered at all. But no damage. Using hot air really does mitigate all of the risks of pulling a chip out. If you, as long as you're careful and don't rush it, make sure that it's moving before you start levering. But let's get the other one. Okay, so working C64, but we will just check it again, just in case. Okay, PLA is up here on this one, as we've already discussed. Still going to be hot. Let's just give the legs a flatten out so they don't ruin my socket. Not very long legs on this, but these sockets tend to work quite well with these chips that aren't well endowed in the leg department. It doesn't want to go in. There we go. What does that do? How typical is that? Working perfectly. Okay, we better tick it. It's very disappointing. Okay, this is going to be a challenge, this one. I can feel it. This one is going to make us work. Cleaned up very nicely. PLA sockets. And I know on a previous video I did put a known good working chip back in a board without a socket. But this is a PLA. This is a MOS PLA, and it's going to break. Maybe not today, probably tomorrow. Right, before we go any further, let's look in this area. What's here where this corrosion is? Oh, it's the PLA and the SID. It's also a little bit the CPU. So maybe I should give this a really good inspection before we go any further. Yeah, looking closer, there's some corrosion on some of these ROM legs in here. There's quite a lot of corrosion on the CIA legs as well, so any of these could have failed. Some of the RAM is corroded as well. Another possibility. Nothing's rotted though. Nothing looks bad. There is something nasty looking up here on the CIA. Yeah, that doesn't look very good there. Can you see that? Just in here is some more serious corrosion going on there. Clean some of this corrosion off. Not corrosion, staining. There's very little corrosion on this side. The only thing I can see that's wrong as such is that CIA pin. So I think I'm happy with the board's condition as it is. That's a good fit. Make sure that we are back where we were. And make sure there's still nothing on the diagnostics. Oi, that white line becoming suddenly brighter. That was weird. A lot of corrosion, could be the slot. A very bright light again. I don't remember if we had an LED on the diagnostics cartridge. Okay, let's scope the CPU and see where we are after that. Okay, starting on the pin 1. Keep these on my wall, but I want this down here where I can see it. Turn it on. Pin 1 is the clocking. Pin 2 is ready, and IRQ is the same. NMI, AEC, VCC, and then we got address line 0. Hang on, address line 0, 1, 2, 3. 3 looks a bit funky. 4. So there's 4. 5, 6. That looks more normal. 7, 8. 8, which doesn't look good at all. 9, 10. That's normal. 11, 12, 13. And then we've got ground, address line 14, 15, and then P5, P4, P3, P2, P1, P0, all high. And then data line 7, 6, 5, 4, 3. Oh, 3 doesn't look. Yeah, 3 looks a bit rough. 2, so does 2. And 1, 0. Read write. You'd expect that to be jumping up and down. Clock out and then reset. I think I've found something. I had a scope around the DRAM, printed out a nice pinout for me to follow. And so we've got data in, which looks normal. The right line is just high. I'm not sure if that is normal, but we'll leave that for now. That's the row address strobe. That is address line 0, address line 2. They look normal. And address line 1, that looks normal. 5 volt is down here. On the other side, and this is a random chip, it's the same on all of them. Address line 7, that doesn't look right. That isn't right at all. And address line 5, address line 4, address line 3, and then above that is address line 6, which also doesn't look normal. So we've got 6 and 7. Address line 6 and 7 don't look normal. Just carry on up. That's the data out, and that's the column, address strobe, and then ground. So 6 and 7 don't look right. So looking at the schematics, we've got the RAM on the right here, and then we've got on the left of these the multiplexers, the 74 LS257s at U13 and U25. Address line 7 and 6 coming into U13, both of them are in the same chip, on pins 10 and 3. So we've got pin 10 is this, that's 8, 9, 10, yeah. Pin 10 is that one, and pin 3 is that one. Both of those look perfectly normal. They're good. But it comes out over here. You can see these address lines on the actual RAM itself. So pin 4 is where address line 6 comes out of the multiplexer. So pin 4 is where it goes bad on the output of this 257. And the other one was, that was 6 and 7 just above it is pin 9, which is this one at the bottom. And that also looks bad on its way out. So I think the problem we've got here is that multiplexer here. Let's turn this off, pop that out and give it a test. This is a Motorola part, so it's not even a MOS part. It's very unusual. Back to my Hacko for this one. We've got the same thing with the pins being bent over to the outside, so I'm just gonna give them all a nudge back into the center of where they're supposed to be. And the reason I'm trying the Hacko on this is that it's useful to compare how the desoldering station feels on the same board. If I just use that desoldering station on this board and then on the next board use the Hacko, it doesn't really tell me anything. I want to see how the Hacko performs in exactly the same set of circumstances. That went much better. It's a smaller chip, but still went much better. And most of the solder is gone from the top. There is still some on that side. I'm actually going to have to heat this and cover this resistor pack. Resistor packs don't like getting hot. Never mind the fact that it will melt. It'll actually stop it being a resistor pack if it gets too hot. There we go. Give myself a little bit of room. It's a smaller chip, so it should come out easier anyway. It's already moving. Definitely score 1 for the Hacko there. All right, let's plug in a chip programmer. Get it the right way up. Put this hot chip in here. Right, and check. We can click on this symbol here and type in 74257 and test. Ah, damn it. How can it not be that chip? Unless the RAM something on the RAM is pulling those address lines down. I am surprised. I really thought I was onto a winner then. Overconfident. Oh well. We keep going, and eventually one of us will give up. It ain't gonna be me. I've put some silver Sharpie on here because that was just the closest Sharpie I had. And it looks like I've taken the solder mask off, but I haven't. And silver Sharpie doesn't come off as easy as black Sharpie. And we continue. I think one of these RAM chips is pulling down that address, or those two address lines. And I can't see which one it is. So I'm not going to start randomly pulling chips yet because I haven't done my due diligence. There's one thing that I haven't done on the other board. This is my test board, but I want to show you something. The one thing I haven't done is test the VIC-2 in another machine or rule out the VIC-2 in other ways. Right, so the problem that I'm looking at here is that the address lines 6 and 7, which appear on these multiplexers on U13, I've already ruled out U13. I can't rule out the memory yet. But there is one place where they only appear by themselves without the other address lines. And that is on VIC-2, on pins 30 and 31. So 49, 8, 7, 6, 5, 4, 3, 2, 1. And that looks reasonably normal. And 30. Possibly normal, not sure. These half signals here could be indicating something, possibly the VIC-2 still. Anyway, they don't just appear on the VIC-2. So the rest of the address lines that are coming out of the RAM here, so this is address line 3, this is address line 2, this is address line 1, this is address line 0, and there's 4, and there's 5, go straight through. They go into these logic chips here, and into this U26 here. They split down, but A6 and A7 don't go straight through to the memory. There is something sitting in between the VIC-2. So again, this is the problem, because I'm finding the fault on the memory side, specifically on this side of the memory, but not on the other side as it comes out. So A6 and A7 go around and they go to U26, which is this long boy down here. 3 and 18, it's a 20 pin chip, so 3, it's got that same signal on there, and 18, it's on the opposite side. Similarly ropey looking. The rest of them don't look like that. And that doesn't look good either. But so that's a suspect. But I think the thing to do is to actually isolate either address line 6 or 7 from the memory. Take the memory out of the equation so that I can rule it out. And there's one clever, simple way of doing that. And he hasn't worked on many C64s before, but he's going to help me with this one. And that's Happy Little Diodes Jim, who does this trick on ZX Spectrums when he has a bad address line or something that he needs to isolate off of the bus. He actually desolders the pin and makes sure it's not touching the board. So I'm going to try that. I'm going to find whichever pin it is on here. We'll try address line 6, and which is pin 13. No, we're going to do 7 because it's in the corner of each one and I won't get confused. So I'm going to desolder each one, and I'm going to try and remove all the solder around it and then maneuver the pin so that it sits in the hole without making any contact. Wish me luck. Right, that's disconnected. How does, what is it we're after? A7, look now. Okay. Not that one then. Right, all of the A7 pins are now desoldered. What's this going to tell us? That the problem is still there. Okay, the one thing I haven't done that I said I was going to do is check this VIC2 in another machine. I'm wishing I'd done that earlier. I might even actually just desolder this socket because this socket is really bad. I think when I took this out of the other machine, all I did in the triage episode, the only thing I did was clean the socket. Oh, the VIC2's working. That's good. That's a good thing. I mean, it would have been an easy fix, but you never want to see a VIC2 dead because they're not easily and cheaply replaced, and it kind of would destroy the value of the machine. Doesn't rule out the socket. Socket. There we go. Don't think that's going to make a big difference, but you never know. It's worth making sure. Oh, that feels much better than the last one. Right, what do we get now? Still that weird white line. I think I'm going to sleep on this one. It's getting a bit late here. And I find that if I just keep going with these things, it doesn't always end up the way I want it to. So I'm looking for a revelation overnight. But at this point, it could be absolutely anything. I am no closer to the truth than I was before I started. Could be the CIAs, could be the ROMs, could be the CPU, could be all of the RAM, could be any of the remaining logic chips, although I'm really reluctant to believe it is because these are usually really reliable. Can't believe it wasn't the PLA. Not sure what to do next, but yeah, I'm going to go and sleep on it. Let's see where we are in the morning. Something may have occurred to me by then. Night. It's the next day. Whilst I had a reasonable night's sleep for a man of my age, I am none the wiser. You can see I've got both my test bench my test board and the trouble board on the bench, and I've been using my oscilloscope, you can see over here, with two probes, and I've been comparing, and basically all of the signals on here, especially on the address bus, but also on the data bus as well, all look really bad. I started chasing down a rabbit hole with A6 and A7 because I found that coming out of this multiplexer was a bad looking signal on A6 and A7, and there's only a couple of places where that appears on the board, which is I think it's U14, which is that one, and U26 and the VIC2, apart from this multiplexer, and then A6 and A7 are on all of the RAM chips. But I then went and looked to check A6 on, so for instance the CPU. I wonder if I can show you over on this. A6 and A7 are pins 13 and 14 on the CPU. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and well, let's look at 12 because 12 is A5. That looks bad. Let's look at 11. That looks bad. I don't know why I didn't look here first. This is actually pin 13 and A6, and that doesn't necessarily look bad, but it shouldn't be pulled high most of the time. And this is A7, which is in a similar predicament. Let's go up to, and then we've got VCC. Right, so we've got address line 0, 1, 2, 3, 4, 5, 6, 7, which is wrong. It shouldn't be. Those signals are all really bad. They look terrible. The problem I've got here at this point is that I could just pop out the CPU, and it could be that, but it could also be any of the ROMs and the CIAs as well. And I misspoke earlier when I said that A6 and A7 is only on, I think what I meant was when A6 and A7 only appear on these VIC-2 is that's the only place where they're unique, not they're the only place where they appear. They are obviously everywhere else as well. So it could be any of these. It could still be the memory. It could, I don't think it is, because this multiplexer doesn't deal with what is this, U25, doesn't deal with A6 and A7, but then the other ones are bad as well. Something is crashing the address bus, is pulling addresses high and where they shouldn't be. And I don't know which chip it is. None of these are particularly hot. The CPU is a bit warmer than I would like. It's actually warm enough to, when I've been probing around and lent on it, it's actually been uncomfortably warm. So I think the only option I've got at this point is to start pulling chips. I can't see any other option. I've got nothing on diagnostics and nothing that the oscilloscope is telling me is pointing to anything in particular. There's no smoking guns. So this one is going to be parts cannon, much as I hate to do it. And I know some people get a bit sniffy about it, but I'm at a loss at the moment. Hot chip. Hot. Hot. Very hot chip. Ah, it stayed black just for a little bit longer than I was expecting. CPU is good. Ah. Oh, it's gonna work. I don't think it's the memory. I think it's more likely a ROM. And with absolutely nothing running, could that be the kernel ROM? Let's put that to one side. I'm going to take a ROM out. I am literally scattergunning this. Please don't work. Oh. It's making me angry now. Where is it? Come here, you. It's actually making me angry. Yeah, no, I think what I'm going to do is turn the cameras off, start pulling chips out. Maybe I might put all the chips back. I don't know. I'm not sure what to do, but I think I need a plan, a way forward, and I don't know what it is. I'll start again. I think that's what I'll do. This isn't my finest hour. I'm at a loss at this stage, and I don't have very many options to continue exploring this. So I can't remember, I think I'd already removed the CPU and maybe the kernel ROM. But as you can see, I've removed all of the custom chips have been removed at this point, and all of them test perfect. Not a problem with any of them. I really thought it was going to be the CPU, and then I really thought it was going to be a ROM, then I really thought it was going to be a CIA, but no. So the next thing I turned to was the memory, and I removed all of the memory, and they all test fine. I have actually just put them back in without sockets because this is Motorola memory. It's very reliable, and there's no need for me to socket this whole board. I also explored the reset circuit and the well, I'll tell you why I researched that first, and that is because the reset on this is a bit sudden. When you turn the computer on, the reset line goes high almost straight away. So it starts low and it goes high. There's meant to be a pause while everything gets power, and then the reset line goes high, which means that the machine is then running. When it's low, the machine is held in reset, and it immediately goes high. I kind of counted that out at the start because I was using this DesTest Max, and it's got a reset switch on it. And so holding the reset button down would normally, if you had a bad reset circuit, you would be able to get the machine to start. Made no difference. But I explored it anyway, and I checked the lines going in and out of the 556 timer chip over here. It's a 555, it's 255 timers in one chip, and half of it deals with the reset circuit and half of it deals with the NMI, the non-maskable interrupt, similar things. And there's nothing wrong with that at all. In fact, the reset, I need to show you this actually. It's quite interesting. Okay, I did print out these pieces of paper, and this one, yeah, this one's the NMI. Right, so there's U20, this 556 timer, and it's got a restore. So when you press the restore key on a C64 keyboard, that activates the NMI, the non-maskable interrupt, and it's kind of a reset that doesn't wipe the memory as far as I know. And that looks, I can't really test that without a keyboard, or I could, but I don't see any problem with that one. But it also goes through U8, this 7406 chip just above, and that's that half of the reset timer circuit. This is the other half. This is the internal reset, and the reset comes in. So 9 and 8 on the 7406. It also goes high straight away. It's going immediately high. Or it should, this is I think this is an inverter, this chip, and it should reflect that pattern. So if I go, all right, it's off, turn it on, it goes high, and then it goes low after a second. So 8 is the output, and that's just going immediately high. And the input is right. That's being generated by that 555 timer. You can see that on pin 9. If I show you, this is pin 9 on that 555 timer. There, that's exactly what it should be doing, but that's the wrong way around. So it goes through this inverter, which should, well, you can see it, what it does. This is the input on that inverter. And that does exactly the same thing. They're basically connected. And then the output is pin 8. It's this one. Let's do it. Right, if I turn it off, I'm going to turn it back on now. Just goes immediately high. Could be that. Could be that 7406. Could be. I don't know. Should have paid more attention to the reset circuit right at the start. Howdy. Right, I've just checked it in the chip tester, in the chip programmer, and it came up bad. So I'm gonna pop it in here in U14, in U8, and see if that does the same thing. I'd be amazed if that, well, I'll be educated. Oh my God, that was it. Just that? Surely not. That's it. Oh my God. The whole time, I just thought it was a bit of a weak reset rather than, because it wasn't holding it in reset, it was just immediately coming out of reset. Just make sure this machine is working. Yeah, it is. Oh, wow. Got a bunch of 7406s here. Okay, we're definitely putting a socket in this one, 14 pin. Oh, I'm such an idiot. Why didn't I check that? Staring me in the face all along. Right, let's put in a tested good one. Oh, interesting. That is quite interesting. What's going on there? Wonder if it's just the variable capacitor. But look, we have a working machine. I'm not having a very good day here. So the problem with the image being monochrome, I searched around, I checked for everything that you need to check on these concerning the color generation, which comes from the chrominance, I think, which is part of the VIC-2 and this 8701 timer chip and the crystal and the associated components. And there's a clock going into the 8701, but there's no clock coming out of it for the chrominance. And so I thought, oh, bad 8701, and I found another one and plugged that in. That's not it. It's around here somewhere. Plugged it in, made no difference. So I then thought, oh, maybe the crystal's gone, and I've tested the crystal, and the crystal is fine. So really, when you think about it, especially how this has gone so far, there's only one variable here that we don't know about, and that's me. So let's have a look under the microscope. Can you see the problem? I'll get a multimeter and I'll test between, oh, I don't know, this point here and this point here. Oh, they seem to be shorted. There's a little bridge there. So this is the back of the VIC-2 socket, and where I've desoldered this, I've just scraped off the solder mask off of this trace, a bit like these points here, which I don't normally worry about because these are tinned. It's not that important. They're not bare copper. They're not going to corrode. But I didn't solder it very carefully, so there we go. Now, if I test between this point here and this point here, there is no short. But did it make a difference? Everything's on the board. Let's hit it. Hey. Okay, so now I can put the SID back in for a start. I can find it. It's really grotty. That'll do. It's probably broken anyway. Just want to see if the SID's working. Ooh. Yes, SID is working. So the only thing I need to do now is to actually check the with the test harness. So let's just unplug that for a second, get the test harness in here, then the keyboard, and then I can edit this video and put it out to my immortal shame. All right, full test. Oh, okay, everything tested good except the keyboard. I put the connector on wrong, put it one pin out. Keyboard okay. It's a nice machine now. Put the modulator back on. Modulator can. Right, that is a complete and fully working C64 that doesn't need anything else to it. And let's just quickly summarize. The VIC-2 is good. The CIAs are both good. All of the ROM chips are good. The CPU was good. The SID is good. The PLA is good. All of the RAM is good. That multiplexer is definitely good. I didn't test any of these logic chips, but they didn't need testing. That 7406, it was bad. That's the only thing. This chip here is the only thing that was wrong with this machine. I introduced another fault over here. It's a good version. Hey. Oh, why did I lose my... Yeah, blew me up. So enough of that. Works. Does need a good clean. Job for you, Paul. Okay, so this was mostly my own fault. I probably didn't need to take 3 days to fix this. If I'd just looked at that reset signal in the first diagnosis and understood what it meant, what fooled me was that the reset signal went high. I know it went high too quickly, but on something like the ZX Spectrum, that's not a problem. And that's what fooled me. I forgot. Lesson learned. Okay, so this one's done. Keyboard repaired, my mistakes repaired, and the 7406 chip to do with the reset circuit replaced, plus a few bonus sockets for the next owner, for when those custom chips do go wrong. Right, time to put this one away.